Okay, ready to go again. This time we're doing F. Got to do F, which is our sixth review, right? That's how many we're doing. It's taking a while. Okay, so again, M105, exam 3, review, and this one is F. Okay, so we're up to problem 15. Right, there's 20, so we're getting there. But again, it's going to take me a while to get this graph done. Right, they show you a picture instantaneously, and it takes me a while to draw these graphs. Okay, so I'm going back 5. -1, -2, -3, -4, -5. Let's put that in there. And that's how far we want to go back. All right, fine. Now, what about upwards? Upwards from the origin, all I need is 1, 2, 3. 1, 2, and 3. To the right, all I need is 1, 2, and 3. Downwards, all I need is -1, -2, and -3. Okay, now let me try to draw this graph. It's coming down like over here, and it goes through the -5. That's not really unimportant, but it happens to do that. Now, right beneath the -4 and across from the -3, that's where I need this. Across from the -3 and beneath the -4, that's a point, and that's where the graph reaches. Then it goes up, and it goes up to the -2. There's another stop, another point, and another stop on the graph. Then it dips down to -2 over here on the y-axis. Dips down over here. There's another point stop there. Then it goes up to 3, across from the 3, and above the 3. So it goes up there. That's where the graph goes next. And then it turns around basically and just goes down the other way forever, and it goes up here forever the other way, etc. Okay, now, so it's going to ask us a question, which is going to turn out easier than you think. The question number A to this graph is all values, give all the values, separate them by commas, that's their usual, all values at which, oh, and it gives the name of this function. This is the graph of function, and it happens to have a name. Its name is G. Okay, so all values at which G, that's the name of our function, that's all we care about, we don't even have to know more about it, we need its graph and we need its name, has a local maximum, Okay, that's going to be A. It won't take long to answer it. Give me a chance to tell you what B is. All local maximum values. So they sound the same. That's what's confusing. All local maximum values of G. Maximum values of G. Now, maximums. We've talked about maximums. Maximums is the highest points. Here's the one highest point, and there's another highest point. So what is the value, if we're talking about local maximum values, well, over here, what's the value? In other words, in height. Well, how far is it on the y-axis? 0. That's one of them. And the other value, local maximum value, is, well, how high is this? It's up 3. I don't care if it's over here, this is 3. What I care about is how high it went. Maximum value. It's up 3. So you put 0 is one height and 3 is the other. That's how you answer B, local maximum values. But values at which, it says values at which, that means they want the points. Give us the points of where this happens. Where does it happen that we have this maximum? Well, the full name of this point, basically, the full label of this point is it's -2 as far as x is concerned, and it's 0 as far as y is concerned. X coordinate -2, and 0 is the y coordinate. What about the coordinates of this other maximum? at which that will be the point. So the point over here is it's 3 on the x-axis, and it's 3 on the it's 3 on the, what is this? 3, yeah, it's 3. It's 3 and 3. So it's 3 on both, and therefore it's 3 comma 3. There we go. All right, so that is the story with this one, 15b, and this problem is over. So those are the two answers. Right here and right here. Okay, let's go to number 16. Let's move the paper up. Paper up. Good. What if you've got given y is equal to 2x minus 9, and a, you've got there's going to be two parts to this question as well, an a and a b, but here comes a. Find equation of a line. You know what that means. Find the equation of a line. And you know what that spells when it says that. That means we need that tool y minus y1, the point slope form of the line. Find equation of line that is parallel to the one that's shown, right? Parallel to this, and passes through, right? I'm going to do that, my little ampersand there, whatever it is, and that's my, and I've used that before on you, and passes through, it's not spelling through right, 5 comma negative 2. Okay, it's supposed to be parallel. If it's supposed to be parallel to this is y equals mx plus b. We don't even have to isolate y. It's already isolated for us. What is the slope? The coefficient of x. What's the slope? 2. All right, that makes our life easier. What do we got to do? We got to take this y minus y1 equals m times x minus x1. That's the point slope form of the line. We got to feed it. And if we feed it, we got to feed it its x1, its y1, and we got to feed it its slope. Okay, y minus 2 equals 2 times x minus 5. That's y plus 2 equals 2x minus 10. And if we got to get the 2 on the other side, it'll turn into y is equal to 2x. Many times they want it in y equals mx plus b form, like we said all semester. So minus 2 on both sides, and it'll be 2x minus 12. And we have done problem A. Okay, B. B is the same exact thing, but here's the instruction. If the line, we want a line that's perpendicular. B is going to be a line that's perpendicular. A line that's perpendicular, right? To our line that's perpendicular to our line, and passes through. Right. Let me put this over here. Passes through a different point, well, also the same point actually, 5 comma negative 2. All right? All right, so if it's perpendicular, what's going to be the slope? This was the slope for A, right? What's going to be the slope for B? What's going to be B's slope? It's going to be the negative reciprocal, right? The m is going to be the negative reciprocal. So what do we have to do with 2? 2 becomes 2 over 1, and negative reciprocal is flip it. 2 is the same thing as 2 over 1. So we make it 1 over 2 with a minus sign. That's what our B's slope is going to be. Okay, now do the exact same thing as we did on the right. Y minus y1 equals m times x minus x1. Okay, now here we need a little bit more. So I'm going to go to another piece of paper because I'm running out. I won't be able to show you everything I need. Let me go to another piece of paper and do B and show it to you much better on the next piece of paper. Just give me a chance here. Another piece of paper. Okay, let me show, what are we in the midst of doing? We're in the midst of doing 16b. Okay, 16b. And the original line, the given line, and it was y equals 2x minus 9. And our question is, now this time I'll write the whole thing out. Question B was find equation of line that is perpendicular perpendicular and passes through 5 comma negative 2. Right? So a lot of the information we already did. Now we know the slope for this is, m is equal to 2. But we need the negative reciprocal, right? How do you get the negative reciprocal? Let me do it again. I did it just before, but I take 2 over 1, flip it, it becomes 1 over 2 with a minus. There it is. The slope that of the line that's perpendicular is going to be m is equal to 1 over 2. I go over here and use my tool, y minus y1 equals m times x minus x1. What do I feed it? I feed it its slope, and I also feed it the x1 and the y1. Okay, y becomes y minus y1 is going to be negative 2 equals the slope, which is negative 1/2, times x minus x1, which is 5. This becomes y plus 2 equals negative 1/2 times x minus 5. Okay, now we've got a problem. We're going to go into fractions, unfortunately. But what we'll have to do is, what do we have? This is negative 1/2. Okay, hold on a second. We've got to change, just got to do a little bit better. Hold one more line, y plus 2, before we get into fractions. Negative 1/2 x. And this turns into positive 5/2. Okay, minus times minus is plus. Now what do we got to do to make this into y equals mx plus b? Minus 2 on both sides. All right, how do you get, this is gone. That's good. This is good. This is good. Or either the 1 is there or just the x is there. Now what about on scrap paper? What is 5/2 minus 2, which is minus 2 over 1? It is the same thing as 5/2 minus, turn this into 2's. 1 times 2 is equal to 2, and 2 times 2 is equal to 4. 5 minus 4/2 is equal to how much? It's equal to 1/2. So what's left over here to put here is plus 1/2. And now we have it in y equals mx plus b in case they want it cleaned up. And the problem is over. That's number 16. Number 17, we definitely need a new piece of paper, and we probably will only get a little bit of it done. Okay. Okay, so I think we're going to just stop this video because we'll need the next video for number 17.